Okay, so we've got a block breaker game here. Cargo run it, and I hit new game and it plays. The problem that I want to solve today is when the ball goes up like that, it doesn't matter, but the paddle can go out of the sort of bounds of the game. So I have a bunch of debug flags turned on. So like the green below the paddle is a collision like a cuboid. The blocks are all collision rigid bodies. And so the outside of this game board, the white line basically, is not a square. So if we look at what that is, if we close this for a second, and we take so left and right, first of all, are just, I'm doing raw key codes. We should switch that to leaf wing, which I just did in the 2D platformer, which worked out really, really well. So that would enable us to do both the keyboard control and like a controller or something like that. But thinking about what the collision structure is for the game board here, then we can see that here where we are spawning in the actual game board border with the collision shape. The collision shape comes from Rapier, which is coming through a higher level crate called Heron, the bird, like Heron. So we go with a custom collision shape component on our entity that is the game board basically. And we use something called a polyline, which allows us to draw a number of points in space. So we go from, I think, bottom left to bottom right to top left. And then it goes and connects all of those lines, basically connects the points with lines. And those lines become the like colliders. So in this way, we can draw kind of whatever kind of level we want, even though this is only going to be a rectangle. So we need to find a way to cause the paddle to stop moving when it intersects with this polyline or butts up against the side of this polyline. So we've got this playing area border component on the border, and I think the paddle also has one. If I scroll, we should see paddle here. So we should be able to do like is the paddle colliding with the playing area border? And maybe the normals will give us something. Maybe the normals will be like, hey, it's on the right or the left with like a positive or a -1. I don't know if that's true. If it is true, then this becomes a little bit easier, I think. If it's not true, so first of all, if it is true, then we can detect just whether the paddle is intersecting with a given playing area border wall. And if it is, then we check the normal. And if the normal is on the right, then we refuse to move the paddle any more rightward. And if it's on the left, which would be a -1, we refuse to move the paddle any more left. If that is not the case, then I think we'll have to take the same approach that we do for the ground detection in the 2D platformer, which will be to add an extra component. I think I actually have that here. Yeah, so we've got a couple of systems here that spawn like a ground sensor for our 2D platformer, and we do ground detection. So whenever that sensor collides with the ground, we set a value, a flag to, yes, we're on the ground. And once it stops colliding, we set it to not be. And we could do that with like a square on the right-hand side of the paddle and the left-hand side of the paddle. And we can build up any set of like, do we want the paddle to go halfway through or anything like that if we wanted to, using that more advanced solution. Okay, so we need to do collision detection for the paddle fairly constantly, and we need to set an additional component. So because I'm doing everything main.rs, I think we're going to do it here because I think movement is in here too. So the paddle movement, where if we press like left or A, then we move left. If not, then we move right, and like etc. So maybe let's try to find something else. Actually, instead of doing events here, is there a way for us to determine whether the paddle is colliding when we do the movement? So instead of breaking this out into an extra thing, we could do, I don't know, rigid body maybe. Let's go check the doc. So in the Heron docs, maybe we get collisions component, which will be filled if present with a list of entities from which the current entity is currently in contact. Okay, so I think this is what we want. This will probably take a type argument. It'll be collision something. I don't see any example usage of it. Let's check the source code. So it is meant to be used as a component. So we've got this collisions here that's defined right here. It's a tuple struct. So it just contains the hash map of entities that are currently colliding with something. It looks like it needs more. Is this all collisions? So it's a hash map of like the paddle entity to the collision data. Okay, so we're just going to copy and paste this query out then. I don't think that we need to mutate it. So we're just going to do this and we're going to have collision. I don't know why we have 2 anonymous lifetimes there. I'm going to make it like this because I think that this is the way that we need to do that. So let's do entity here, velocity, and this, and this, get this, entity, velocity, mute, and then we remove the mute from the beginning. And I don't know that we need entity there. So for each of these, we're going to need to do a check here. So we query for playing area border. So maybe the rigid body with a playing area border. And this can be, we'll call this entity and the rigid body. I don't know that we need the rigid body, but I'm going to include it in the query entity. So we've got the wall, which there should only be one of. So we could do let wall equal wall.single, and that should panic if we don't have a wall. If we don't have a wall, then we might just need to iterate over it. Like if we're running movement at a time when there isn't a wall, which is possible. We can write more resilient code, but this is easier to understand. So I'm going to write it like this to start. So collisions.get entity if let this. I don't need parens because I am not writing JavaScript. Ta-da. If let, actually we do need that, but not here. So if let something equals collisions. Is this not sum? Cargo build. Let's do cargo watch x check instead, and just keep that running on the side here. Enum result found option if okay thing. I thought that was going to be an option because that was a hash map, but maybe there's something else going on. So if it's okay, then thing is a collisions. Let's just keep this as thing for a moment. Thing. So contains is interesting. Is this just a vec of the entities, basically? Collision data. Can we debug this collision data? We could also go look it up, but I'm curious to see if we're getting any of this actually right at the moment. So I'm going to run it. New game, yada, yada, ball hit. So there's no collision happening for that. It doesn't look like there's a collision happening at all, actually. I wonder if that data doesn't get filled. Interesting. Are we not supposed to use collisions? And this is probably a U, cannot be formatted. This is a query, isn't it? So, that's the problem. It's a query, single. I don't know that it is supposed to be single, but we were passing in an entity to this query and we weren't really looking for the query in the first place. So let's do like all collision. We'll name it query and then let all collision query, all collisions equals all collisions query.single. So this is going to be all collisions. And if we look at the types, we get collisions on top there. So I thought we were going to have a get on all collisions. Apparently not. What do we have on? What is collision data? It's an iterator. So for collider and all collisions.collision data, collider.collision data is the wrong thing to do. So we debug collider. So now we should actually see some collisions, hopefully. Task has failed. Collisions, unwrap on an error value, 529. 529 is our all collisions query. So maybe there's more. So let's do all collision query dot iter. So now we're looping over it. So if the problem is that we have, it was no entities, wasn't it? It actually does tell us that. So we get nothing for this playing area collider, which is not good. Are we not supposed to be using this collisions? I think I'm using it wrong at the very best. This fills it up. This is a test. Okay, so app world spawn. So this is a test inside of Heron core, which is where the collisions struct lives. So this is using like direct access into the world to get an entity to get the collisions. Interesting. Okay, so you can have an entity, and on that entity, you can get the collision. Maybe we should be taking that approach. And so let's comment this out for a second, and let's do this, and let's do commands.entity, entity. We don't have commands, so I need to add it to the query. Command. This is going to be a mutable reference. Where does this get come from? Is there a trait defined here? Collision data, collision event, rigid body, bevy prelude. What is get? I thought get was on an entity. Do we bring in collision data, collision layers, events, iterator visiting data from all colliding entities in arbitrary order? I do think, I'm not sure if we need to insert this collisions component on our, if we do, then we need to find our paddle string. Let's do the bevy doc. Now let's do entity, the entity here, and then components of a specific entity can be accessed using query get. Oh, it's query get. It's not. So I misunderstood this, I think. Where are we? Entity. So entity.get. this is a function on world, so it's not the same one that we have on command. So this return type is probably not the same either. So if we look at world and we look for entity, this returns an entity ref, whereas I think commands returns something else. Commands, entity, that's the entity should be in the left here. And this returns an entity commands. Those are two different things. So we don't have an entity ref, we have an entity commands. So how do we get an entity? I don't know that we need one, but there's no documentation for what this is. Interesting. So entity ref.get is an option T, where T is a component. So it's just getting the component. So we can actually not have to do this at all, because what we can do is, let's do entity first. I'll put collisions here, which has to go everywhere. Collision. So if we debug a collision here, why do I keep spelling it like that? Collision. Do I need to iter over this explicitly? It doesn't look like I need to, but it is complaining. Heron collisions is not an iterator. Is it that hash map? Is that why? Let's just debug this. We'll debug entities. Apparently that doesn't implement. Oh, because it's an iterator. Because type annotations are needed. Entity, I think this will be. Let's find out what it wants. Cannot infer type. Fine. We'll put unit here and then you'll tell me why I'm wrong. Cannot, a value of type unit cannot be built from entity. So they are entities. So this is everything. So this says to me that we don't have an iterator here. We have t.entities, which is an iterator. So we'll call this all collisions. So this should be a list of everything that's currently colliding, or it will be in error with system movement. Not my favorite error here. I think it's for collisions. Let's make this error smaller. Required in this bound by condition system set with system. So this is the trait bound error because I did something like, yeah. So that'll be a problem because world query isn't implemented unless it has, but there's a different problem. Into system is not implemented for, do we need commands anymore? We don't need, I might have just typed commands incorrectly. So check this out. So now we get those colliders. So we are getting the IDs now. So unfortunately, we need to reverse the logic here. Now we do only ever have one paddle. So it'll be something like this. And then we can grab this, get rid of all of that. We need one down here. And we need to get rid of that, most of that, but not all of it. And this. Okay, if press, else this for, this is not enough braces. And now we cargo auto format. I love cargo auto format. So let's get rid of the type inlays. So we have the entity here. We aren't using entity at the moment. Paddles.itermute for collider in this. Debug collider. So you see how this might be easier if we actually abstracted this into a different system, because then it could turn on and off and we would only need to query it here instead of doing all of this logic and multiple loops. But I'll do that later. So this is input pressed for collider and collisions entities. Do we have the wall? Here's the wall. Let's bring the wall back. Actually, let's do watch. So that seems fine. We have wall. Wall will be single. It'll be wall.0. We don't need collisions.entities here. We need collisions.the collision data, because not only do we need, so what do we get in collision data? Go back here. You know, if I can type, I would be able to get to the docs a lot faster. Collision data, private fields, the rigid body entity, the normals. The normals is what we want. So rigid body entity and normal. So if collider.rigid body entity equals wall.0, collider dot, hopefully we can debug this. And hopefully this looks like what we wanted. So new game, we do this, yada yada, we're hitting the ball up, and then we get this normal. Normal there is 1, 0, 0, and it's negative 1, 0, 0 over here. So that's exactly what we want, actually. So if we do this, I think it's XYZ. So X is what we want. And then if we press A, let's do let mute wall collision equals this normal. And then this, we don't need to debug anymore. So this is only going to collide with one wall at a time. So we can do wall collision equals this. Do we need to clone? Why? So we have an issue here. I'm not sure why. Because I made it an option. So there are situations in which we could not be colliding. So this always starts out as none and then gets set to something. So we don't need to worry about unsetting it here. And A is if wall let sum, I don't think we need the thing inside. We do need the thing inside. So if let sum value equals wall collision. No, we could do this easier or more simply, but we'll do it like this for the moment. I don't like comparing floats. We wouldn't need to. We can change this to an enum later. If the wall is on the left, then we do nothing else. We do something else. This is going to tell me that I can't compare this. Expected vec normal 0. And I'm going to debug the normals out again. Collider.normals. I thought normals was going to give me only what I wanted. So we go left and right. Collider. We can't move left if it's on the right now. So it's an array. Why is normals an array? I don't know. I don't think there can be multiple normals because we're in 2D. So I'm just going to do that. Will panic if I am wrong. But let's hope I'm not wrong. Okay. This is if the normal is -1, do nothing. Otherwise, set the velocity. Let's save that. Let's run this and see if I got the math right. Can't move left at all. Interesting. I can only move left if I'm in the right-hand side wall. So it's a little awkward. I do have it doing the right thing, or like we are preventing movement, right? But it's awkward that it's not doing. I need to log these numbers out and see if I can, because right always works. So right is 500. Left is if the wall collision exists. So if the wall collision doesn't exist, we still need to. That's my problem. So basically, if some value is some -1, then we do nothing. Otherwise, so this is kind of an ugly way to code that, but it should prove that this is correct. So we run that, and then I'm not sure that the -1 is the right name. So this works, and then we can't move left here, but we can hold left, which is interesting. So there's a different issue here where it won't stop if it's already moving because why? Anyway, that's a bug that I will fix, but it does prevent us from moving left here. Like I can't move left right now because we're in the wall. I can move right, and then I'll do the same thing on the right wall. And the only other thing to do is to figure out why, if you just move through, you can go through. Let's see. If value is -1, if velocity is less than 0, let's do velocity equals. So we just stop the x component of velocity. Linear.x is less than. So that should be it. If we're moving left, then we need to, oops, that was my fault. So on the right-hand side here, kick the ball left. It should just stop and then come through. And then it should stop and we can't get it to go any further and then through. So depending on how we want this to look, see our paddle can technically go into that wall. I kind of like that. So I think I'm not going to change it, but we now have prevented it from moving past this wall. And we're doing the same thing on the right, which is bad. So why is it happening on the right? If value is -1, oh, because we can make it out onto the right-hand side. Okay, that makes sense. If we pass more than halfway with the paddle, then this breaks. So let's copy and paste this into the right-hand side, and we'll take out the negatives, and that should work because the normals for the playing area should be -1 on the left and +1 on the right, unless I totally just messed up. Yeah, so we not only need the negatives flipped, but we need the detection about whether the speed is going positive or -500. So this should stop. It doesn't go as far into the wall, and this should stop. So they stop, and we have no problems. So that's pretty sweet. It was a little bit roundabout of a way to get here, but we do now stop the paddle on either end and prevent it from escaping the playing field. So this is actually much nicer than I thought it was going to be. One last thing I want to, so let me explain this first. We are getting all of the paddles on the screen. We only have one. So we make the query for the entity, the set of collisions with the paddle, and the velocity. And then we also query for the wall, which is the playing area. We only have one wall, so we do .single. But for the set of all paddles, we do a for loop over them. We're iterating with iter_mute because we need to change the velocity of the paddles. So we start off with, we are not colliding with a wall. And then for all of the collision data, if the collider is the wall, so the rigid body entity is the same as the wall's entity, which means that the collider is the wall, then we set the wall collision variable, which we initialized here to none, to sum the value of the normal. So this is something that I'd like to clean up into either a right or a left in a different system so that we can always tell whether the paddle is currently colliding with the left or the right wall. But once we do that, we either get a sum -1 or a sum 1 here, or it's none if it's not colliding with anything. If it's not colliding with anything, we don't need to care. And then down here, whenever an input key is pressed, we take the value that we have, we determine whether it is the relevant wall. So if we're moving left, we need to detect against -1, which is the left-hand wall. And if it is colliding, then we set the velocity to 0 so it doesn't move, or we can't move left anymore. And if it's not, then we let it move left. And the same thing for the right. So if the wall on the right is colliding with the paddle, then the normal for the right-hand side wall is 1 for the X plane. So we've either got -1 or 1 on the X plane because the paddle is on the left-hand side of the wall it's hitting on the right. So if the velocity is moving in a positive direction, that is, it's greater than 0, then we set the velocity to 0 so it stops moving. Otherwise, what we do is set the velocity to 500 because that's the speed of our paddle. And if nothing's happening and there's no input, then we get zeros. So that's actually much more concise than what I thought we were going to have to do. And I might actually go back because we were already detecting these intersecting entities here. I might go back and take this and update the 2D platformer because this ground detection can actually happen. Well, technically it's already happening and we only need to filter out the entities that we don't care about. So if we go to the system in the 2D platformer, what I was going to do is something like this, which iterates over all of the sensors and the colliders and whatnot. But we don't actually need to read this event reader. We can just get all of the collisions for this sensor, which is even better because somebody else is already tracking all of these colliders. Now, the one thing that is nice is that we get to control a little bit more in the 2D platformer because we are doing this manually. We get to block out the sensors here. Yeah, I think that code's going to work better in the 2D platformer using the collision or the collisions component, which is super exciting. So I'm happy that works out. I'm going to clean up this code a little bit because all of these if statements here, while they work, they don't read particularly well. Like if I come back to this code in 6 months, I'm going to be like, okay, what does -1 mean? Oh, okay, that's a normal. But yeah, I'm super excited about that. Just a quick one today, maybe a little bit longer than usual, about getting Heron and Rapier inside of Bevy to detect collisions to prevent a player from moving in somewhere we don't want. So I will see you next time. Next time is probably going to be a 2D platformer video. So look forward to that.